In this exercise, we're considering a subspace of R4, four-dimensional real space, which is defined to be the span of these three vectors, and we give it a name, we call it U. The span is always a subspace. And also notice that for consistency, I just make sure that they all have four components, so we really are in R4. Okay, if it's a subspace, then we can find the basis for it and also the dimension of U. Part B is a more unusual question. We usually have the reverse kind of question, where we give a system of linear equations, homogeneous, and we look for its solution space. This time we start with the solution space, and we have to reverse engineer it to get a system of homogeneous equations. Now, if it wasn't for B, we would have a matrix. We'd start off with matrices, and we'd have a matrix with 3 rows with these 3 in. But because of part B, part B, we put in an extra row, x, y, z, t, whatever 4 variables we would use for a system with 4 unknowns. And basically, I'm teaching this technique through this example. We haven't seen this before, or maybe you have. And as you might have guessed, we probably want to bring this to row echelon form. That's pretty much what we do with matrices. As usual, we want to get zeros below this one here, and we subtract multiples of this first row from the others, especially the last one. Just to show you the last one, we're going to subtract x times this row from this row, so that would be this row operation. And when we've done those row operations, we get this. Of course, you can always pause at any stage and verify the computations. I'm not going to dwell on it. Now we have zeros here. Now next we want a 0 here and here. And so what we'll do is, to get a 0 here, we'll just add twice the second row to the third.